Welcome back. Now let's start with mappings. We are done with the relations and functions. And in functions, a quick recap. In functions, we were given a formula. And then with the formula, we were able to come up with the values of y, or better still, the codomain or the range. Now, you remember I told you at the latter part of the video that in mappings, we are basically going to look at how to derive the formula, right? So in this video, I think we were supposed to, or we are supposed to just delve deep into the rules for finding the formulas. But you know, on this channel, our basic thing is to build the momentum, give you the overview of what is expected. So we are going to look at the basic types of mappings, right, without involving calculations. Then the subsequent ones, we are going to look at how to come up with the rules or the formula, or better still, the formulas, as some people will say. So let's look at mappings. We are saying that mapping is a relation in which each element in the domain maps onto only one member in the codomain. Now, be very keen on the wording of the definition, right? Don't take any of them for granted. We are saying that in mapping, is actually what a relation, a type of relation in which each member of the domain, by now you know what a domain and a codomain means, maps onto only one member in the codomain. That is the definition, simple as ABC. Don't think outside the box, just think within the box. Now, from this definition, we can say that a one-to-one relation and many-to-one relation are mappings. We also saw the same thing in functions, where we said many-to-one, right? Many-to-one, and then one-to-one relation is a function. Here we are saying the same thing, that one-to-one and then many-to-one are also mappings, because we are going to deal with calculations and they should have image. So the main idea about functions and mappings is that we should have image. An image, you know what it means. So now, so we are saying that, note, right, one-to-one relation and many-to-many relation are not mappings. The same thing was applicable to functions. Now let's look at the various ways of describing mapping. The first one, the simplest one, is what? The mapping by diagrams. This one is a diagram. You have the X, or the domain elements in one container, I call it one container, and then being mapped or linked onto another set of elements in another container called the codomain. Right, so here you can see that one element mapped onto one element mapped onto one. You get a point. So 1:1. That's one thing. Now the second one is what? Set of ordered pairs. For example, into curly bracket, the whole set, we have a sub bracket because 0 and 0, 1 and 2, 2 and 4, and then 3 and 2. So these are ordered pairs. So instead of just mapping them like this, right, 0 going to 0, 1 going to 2, 2 to 4, and then 3 to 1, we can just go straight by bringing them the x coordinates and then y coordinates. You understand? So we are just simplifying them, avoiding brackets, avoiding diagrams. So this is it. It's the simplest way. Now the C point is what? Algebraic relations. So here we are setting the rule or formula. For example, y is equal to 2x. This is the main idea, the main calculation, the main concept, the main focus, the main objective of this video on this topic, mapping. It starts from algebraic relations, and then the last one is graphs, right? So the first one is deriving the formulas, deriving the rule, right? So some will call the principle, so the formula. So that is it. Then we deal with what? The last but not the least, the graphs. So the graphs, I think, I don't know how to even do this when it's time. Since I'm not going live and I'm doing this video, I don't know. I think when we get there, we know how to cross the river. So basically, this is what we are talking about. So the one, we are familiar with that, and then this one be the sets of ordered pairs, and then the algebraic relations. Now bear in mind, and when it comes to C, finding the formulas, we will still need another style of this mapping diagrams. So don't worry. So that is it. So basically, now going forward, we'll be looking at how to determine the rule for a given mapping, right? So I just want to whet your appetites, right? Or give you what is ahead. So we'll be looking at, for the types of mappings that fall under these ones, that's algebraic relations, we have the linear mapping, we have the inspection, and then we have the exponential. So under these particular one, we have 3 types. And then this is where we will be doing the calculations, deriving the formulas. This is where you actually put your understanding of whatever we have learned so far into practice, right? So we're deriving the formulas, and each of these subtopics have procedures or ways to actually go around them. They are not the same, right? But you need one to go on to the next. So that is the overview of what mappings are, right? So okay, let me see something. We have some examples, and we are saying that which of the following relations is our mappings. We have I and II. So which one of them is for mapping? So mappings, we said we have 1-to-1, and then we have many to 1, right? So this is 1-to-1 is correct. Now here, this is not. Why is it so? Even though one maps onto one maps on one maps onto one, by here, this one has no connection. Why are we saying so? Because per definition, we are saying that each. So that is the technical aspect of the definition that I was drawing your attention to. That we are saying each, right? In which each element. So if you are here and you are not connected, it violates. And then if the vice versa could also be the same, when maybe element could be here, but it has no connection from here, that is not. So just to give you the overview of what mappings are. So I will see the next one. Stay blessed, watch, like, subscribe, share. Let's see to Operation 1K, and then we'll start going live. I will see you soon in the next one. Bye for now.